Okay, so we're just going to look at this one here. This is a box. So what's it say here? So a block of wood is in the shape of a cube, square ends. So there's the square ends. The length of the block is y. The sum of the length of the block and the perimeter at one end is 12 centimeters. So the perimeter is it says the perimeter of one end. So that's x, x, and x. So the perimeter would be 4x, and then it's plus the length of the block. So 4x plus y, because y is the length of the block, equals 12. That's what they say, 12. So that gives me my y in terms of x. Okay, part B. So find the volume. So the volume is area times the height. The area is x times the height, which is y, or you could go x times y times x. So you end up with x squared y. Okay, now that is not all in terms of x. So we go back to getting where we have y in terms of x, and then we can just use that to sub in for the y. So that's going to be x squared 12 minus 4x, 12x squared minus 4x cubed. Okay, and then the last part of this, find the largest possible volume of the block. So the volume would be when v dash equals 0. So find v dash, which is 24x minus 12x squared. Make v dash equal 0. So 24x minus 12x squared equals 0. 12x 2 minus x equals 0. 12x equals 0, x equals 0. 2 equals x. Okay, because it's 2 minus x is 0. If you bring the x over, x equals 2. Now, x equals 0, that's no solution because there would be no box because the side length would be 0. What we need to do is with the x equals 2, we want to check it is a maximum because we wanted the largest possible volume. And the largest is a maximum. So you need to, the easiest thing to do here is to find v double dash. So if we go back up to v dash and differentiate that, that would be 24 minus 24x. Okay, if you put in x equals 2, you get 24. Now I'm just going to take that 1 minus x, so it's 24, 1 minus 2. And you notice that that is negative, therefore it is a maximum at x equals 2. Now, question is, have I answered the question? What is the largest possible volume? So I've only found x for the largest possible volume. I haven't found the largest possible volume. So the volume formula is way back up here, 12x squared minus 4x cubed. 12x squared minus 4x cubed. So you then have to put the 2 in there. So 4 12s are 48 minus 4 8s are 32. So that would be 16. What units are we talking here? Centimeters. So it's 16 centimeters cubed for the volume. That's it. Okay, so question 4. All right, so question 4, we've got this situation. Now, when you see a cone, Pythagoras' theorem is either going to come into it, or later on you'll see there will be some with similar triangles. So that's like c squared is a squared plus b squared. And that's usually what you use to get, like, it says to get the radius in terms of the base. So we're focusing in on that triangle there. This is x, 6, and r. So r squared plus x squared equals 6 squared. That will help form that relationship between your two variables. They want to get r in terms of x. So bring the x to the other side. That'll be 36 because 6 squared, 6 times 6, 36. R is root 36 minus x squared. You only have to put the positive because it is a length. Okay, so that answers the first part. Then we want to express the volume in terms of x. So what is the volume of a cone? Now it takes 3 cones to fill a cylinder. So the volume is 1/3 times the area of the cylinder. So it's 1/3 pi times r squared times x. So we want to get the volume in terms of x. So it's the r we need to get rid of. So if we go back up to here where we found our r, it's 1/3 pi times root 36 minus x squared times x. When you square a square root, it disappears. So it's 1/3 times pi, 36 minus x squared times x. So you can keep this constant out because it will just times the derivative. And rather than doing this as a UV, because it's two things times, it's really easy just to expand that and get 36x minus x cubed. Okay, so B's done. Now the actual question is, find the vertical height. So the vertical height is x for when the volume is a max. So I have the volume. The volume will be a max when we have to find B dash, make B dash equal 0, solve, and when we sub it back in, B double dash has to be negative for a max. So let's just have a quick look at that then. So I have V equals 1/3 pi 36x minus x cubed. You have to learn just to multiply these constants through. So you get 1/3 pi 36, because 36x, the x disappears, goes to 36, 3x squared. That's going to be V dash. So V dash equals 0. And the beauty of the constant out the front is that it can cancel out because you just divide by 1/3 pi. And 0 divided by 1/3 pi is 0. 36 minus 3x squared is 0. 3x, that'll be 12 minus x equals 0. So 3x is 0 and 12 minus x is 0, so x equals 12. Okay. Sorry, it's x squared, isn't it? So that means x equals plus or minus root 12. So you just go, you don't do the plus or minus, sorry. You just go 2 root 3. Because root 12 equals root 4 times root 3. So it's 2 root 3. Okay. All right, so, and I took the positive. Main reason I took the positive is because because it is a length, so you can't have negative. All right, so 1 mark for differentiating, 1 mark for solving, last mark for, you need to check if it's a max or min, and there could potentially be another mark for just making sure that you actually answer the question. So check for max min. I could find V double dash, or I could use V dash. If V double dash is easy, which it is here, you go 1/3 pi. Now when you differentiate 36, 36 is a number, so it goes to 0. And then minus 3x squared will go to minus 6x. So if you put in x equals 2 root 3, that's 1/3 pi minus 6 times 2 root 3. That's minus 12 root 3. We can see that this is negative. So therefore it is a maximum at x equals 2 root 3. So always go back, make sure you answer the question, find the vertical height, so that's x. So I have found x for which it is a maximum, so that means that I have actually answered the question. Okay. All right, so we're just going to stop that one.